Sine of pi over 6. This is going to be a pretty common trig problem, and we're just barely getting into it, but it's not too bad. So the sine of pi over 6, they give it to you in terms of radians. So first, to get it familiar to us, let's convert it to degrees. So I'm going to take pi over 6, and all you need to remember is to convert. All you're going to use is 180 over pi, or you're going to use or pi over 180. And because I want to cancel the pi, there's a pi on top, I'm going to use this one. Pi on bottom, 180 on top. And then your pi's cancel, so you have 180 over 6, which equals, in degrees, that's the exact same thing as 30 degrees. So 30 degrees, all of your trig is going to come from the triangle 30, 60, 90, or the 45, 45, 90. So let's just draw one real quick. And let's make this 30, 60, 90. Alright, now, the 30, 60, 90, you don't need to memorize anything. That's the beauty of it. The 30, 60, 90 is actually, it came from an equilateral triangle where each of the sides are congruent and each of the angles are 60 degrees. So I look at this one, and you look at the 30, and that was the angle that got cut in half. So if I draw the rest of the triangle, there we go. Now it's a 60, that's a 60, and that together they're 60. So there's your equilateral triangle, and you make up any measure you want for the sides. So if I say that each of these sides are 10, there's my equilateral triangle. All sides the same, all angles the same, and you have cut this equilateral in half. So you got a 90 degree, this 90 degree angle actually cuts the base into two congruent sides, and they're each 5 by, each 5. Now the altitude, you can do Pythagorean theorem to find this altitude, or for any 30, 60, 90 triangle, it's always going to be the same. It's going to be the side that got cut in half, so it was 10, but it got cut in half to 5, and it's going to be multiplied by the square root of 3. So this triangle right here, this 30, 60, 90, if I said that was 10 and then I cut it in half, that's 5. Your altitude, the height, is going to be 5 times the square root of 3. So now what they want is the sine of the 30 degree angles. And I know SOHCAHTOA, sine equals, it's a fraction, it's opposite over hypotenuse. So look at this triangle. In relationship to 30 degrees, the opposite one is 5. So it's going to be 5 over the hypotenuse, which is opposite the 90, 5 over 10, it's 1/2. And for any 30, 60, 90, it's always going to simplify to 1/2. So that's a pretty common trig problem, and there's probably going to be a couple just like that on the test. Number 2. Okay, this is a good problem. Using the calculator, find, that is the inverse right there. The inverse cosine of 1/2. So they want you to find the angle. They know the fraction. Okay, start right here. Cosine is adjacent over hypotenuse, and 1/2. All of this trig is going to come from the 30, 60, 90, or the 45, 45, 90. Remember the 45, 45, 90, that comes from a square. If all these sides are the same and you cut the square in half, you make a diagonal, you've just created an isosceles right triangle. So the base is 4, the height is 4, and your diagonal is always going to be 4 times the square root of 2. So the cosine is a half. I just barely found the sine is a half, so I'm going to stick, I don't think I can get a half out of these numbers, 4, 4, 4, 4, 4 times the square root of 2. So I'll bet you money it comes from this 30, 60, 90. Here was my 30, 60, 90. I'm going to use the same measurements as before. That's 10, that's 5, and this was 5 times the square root of 3. I know I can get a half out of this 30, 60, 90 because I just did it. So the cosine, adjacent over hypotenuse, I want the fraction 5 over 10. Whoops, 5 over 10, because that equals 1/2. So the 5 is adjacent to what angle? If you look at this 60-degree angle right here, the adjacent is 5 and the hypotenuse, so adjacent's 5, hypotenuse is 10, so I know that they're talking about the 60-degree angle. So going backwards, if they give you the fraction, can you figure out what angle that came from? And the answer to this one is it's got to be the 60-degree angle. But your answers A, B, C, D are not in degrees. So we're going to take 60 degrees and we're going to convert it to radians. So I'm going to multiply it by, I'm going to go pi over 180. Put that over 1. So I'm going to have 60 pi over 180. And if I reduce the fraction 60 over 180, I'm going to have pi over, is that pi over 3? So your answer is C. Alright, factor 2x squared plus 7x minus 15. Now, if you don't know how to do this, this is a perfect problem where you can use your street smarts, and you just start with A and start with your answers and work forward till you get it. Do distributive property on each one, go through them all till you find the one that gives you the answer, 2x squared plus 7x minus 15. Factoring, I'm going to do it that way real quick. You're going to change this trinomial, there's 3 terms, you're going to change it into a polynomial with 4 terms. So you're going to take the first and keep it. That second one, that 7x, you're going to split it up into 2 things that add and give you 7x. And here's how you find out what those 2 terms are. You multiply 2 times a negative 15, and that is a negative 30. Okay, factors of 30 are, let's see, 1 and 30, 2 and 15, 3 and 10. Okay, I'm going to stop right there. 3 and 10 I can get a 7 out of. They need to multiply and give you a negative 30, so one of them's got to be negative, one of them's got to be positive. And if I add them, I have more positives than negatives. So I'm going to go 10x and a negative 3x, because that adds and gives you 7x. Okay, grouping. I'm going to group these first 2 together. 2x squared and 10x, I'm going to divide them both by the GCF. 2x, so 2x multiplied by x plus 5. And the next group, this negative 3x and negative 15, they're both negative, so I can factor out a negative, and I'm going to factor out a negative 3. So it's going to be x plus 5. Okay, the x plus 5 shows up in both terms. That always happens. So it's going to be x plus 5 in one group times 2x minus 3 in the second group. And where is that? That is C. Which of the following is a relation? A relation is just a collection of ordered pairs. So we're going to go with D. When a point xy is placed on the unit circle, the tangent function is defined as, again, this is right where we are, but we just don't have time to get into it before the test. So the unit circle, what they're talking about is this. If you, on the coordinate plane, call that 1, call that 1, call that negative 1, call that negative 1. If you draw a circle that has a radius of 1 and you put it in the coordinate plane, this is called the unit circle. So let's say I've got right there, let's say I make an angle there, I'm going to call that theta. I've got a 90-degree triangle. We're going to call this x, we're going to call this y. So the tangent function is defined as tangent of theta equals opposite over adjacent So it's going to be y over x. Here's theta right here. Opposite of theta is y. Adjacent to theta is x. So I'm going to go with B. Okay, what's the solution to the absolute value of x plus 3 is less than 7. Now what you need to remember about absolute value is its distance, and you need to account for both directions. You need to account for the negative direction and the positive direction. So, because if I have you guess a number between 1 to 5 and you tell me 3 and I tell you you're 1 off, you don't know what direction you are. You're 1 too low or you 1 too high, so it could either be a 2 or it could be a 4. So this is kind of like absolute value. There's two directions you could go. So move number 1, you just set it up and solve it as it is. Move number 2, you set it up, you flip the inequality, whoops, it's just greater than, and then you solve it for the opposite, solve it for negative 7. So if I'm minus 3, first one is going to be x is less than 4. Second one, minus 3, x is going to be greater than a negative 10. So I know it's not B or C, because those have less than and equal to. So I look at A. X is less than a negative 10. Nope, because x has to be greater than a negative 10. So it's got to be D. We're going to go with D. What point is common to every exponential function of the form y equals a to the x? Y equals a to the x. This might be one where you have no idea even what they're asking for. But they give you 4 order pairs, xy, 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 xy. So what they're saying is, no matter if you have y equals 2 to the x, or y equals negative 10 to the x, or y equals 0.5 to the x, no matter what you have for a, if you change all these a's, which of these points, if you plug it in, is going to be common? It's going to give you the exact same answer no matter what your function is. So I got 3 different functions, and I know that it is there's a phenomena that if you have any number and you raise it to the 0 power, your answer is 1. So if I have 0.5 to the 0, my answer is 1. If I have 2 to the 0, my answer is 1. If I have negative 10 raised to the 0, my answer is 1. So I know that if I plug a 0 in right here, right there for the x, no matter what the base is, it's going to be 1. So I like B. B says if you plug in 0 for x, your answer is going to be 1. Your output is going to be 1. Multiply to find the product. Okay, I is imaginary numbers. All you need to know is I squared is a negative 1. I is equal to the square root of a negative 1. Distributive property, 3 times 4 is 12. 3 times a negative I is negative 3i. 2i times 4 is 8i. And 2i times a minus I is a minus 2i squared. Combine these two middle terms, so it's going to be 12 plus 5i minus 2i squared. And I'm going to substitute this negative 1 in place of 2, or in place of the I squared, so it's really a negative 2 times a negative 1, and a negative 2 times negative 1 is a positive 2. So you got 5i plus 2 plus 12. Combine your terms, you should have 14 plus 5i. So that matches up with D. Alright, so kind of a story problem. And it looks like your answers A, B, C, D. Looks like they're in the form of a system of equations. So let's read it. You might have to read it a few times. 4 bags of oranges and 5 cartons of ice cream are going to cost you $7.76. 3 bags of oranges and 2 cartons of ice cream are going to cost you $2.85 less. What does a bag of oranges cost? So in the problem, the ice cream, 1 bag and 1 carton of ice cream do not change. So two people walked in and bought different amounts. Can you figure out how much one bag of oranges and one carton of ice cream cost? And that's the beauty of a system. So here's what we don't know. I'm going to say I is ice cream and O is oranges. So somebody came in and bought 4 bags of oranges. So 4 times the cost of orange, and I have no idea what that is. And then they added 5 cartons of ice cream. So if I do 5 times the cost of ice cream, and if I add those two together, he paid $7.76. Now someone else came in and they bought 3 bags of oranges, and they only bought 2 cartons of ice cream, and they paid $2.85 less than the first guy. So I'm going to minus $2.85. So they paid, what did they pay? They paid $4.91. So it looks like this. They're using x's and y's. So the top equation is going to be 4x plus 5y equals 776, and we're using 3x plus 2y equals 491, and that is, where is that? Is that not even up there? Alright, it's not A. This might be a typo. I kind of like D, but I'll bet it should say 4x plus 5y. I'll bet you that's a typo. I'll bet that should be a y, because if it was a y, 4x plus 5y equals 776, 3x plus 2y equals 491. I'll bet you it's D, so I'll bet you that's just a typo. It's kind of a bad problem. Alright, sine of 11 pi over 3. Another radians. This is one we're just barely getting into. So first of all, the sine of 11 pi over 3, let's change it to degrees and see if that is going to be either the 45-45-90 triangle or the 30-60-90. So I'm going to times it by 180 over pi. Okay, my pi's are going to cancel, and I'm going to cross cancel this guy. 180 divided by 3. I'm going to change that to a 1. I'm going to change that to a 60. So 60 times 11, is that 660? So we have got 660 degrees. Okay, now 660, I know that's a full circle. That's 360. And there is 300. Well, let's see. That's 360 plus 270. So what I'm going to do, I'm just going to get on the calculator. I'm going to do 660 minus a full circle minus 360, enter, is 300 degrees left over. So if I minus 360, I have 300 degrees left over. So there's the full circle. I add 90, 180, 270, and I need to stop at 300, so I need to go 30 degrees more right there. And there is my line. My angle is going to look like this. Alright, so if right here is 30 degrees, I know that this guy right here is 60 degrees. So I'm going to look at this angle right here. This angle happens to be a 60-degree angle. And again, we're going to use the unit circle. So the unit circle tells me this, that I have got 1, 1, 1, 1. I've got a circle that goes through my coordinate plane, and the radius is 1. So I'm looking at this angle right here. That is 60 degrees, and I know that that is 1 because it goes from the origin and it hits my circle, so I know that measure is 1. So look at this, I'm going to go straight up perpendicular to the x-axis, and what we've just made, I just made a 90-degree triangle. So this is 1 and this is 30. Okay, now I'm going to use my little trick and I'm going to draw the rest of the triangle. So I know that this angle 30 got cut in half. It used to be a 60, 60, 60, and all of these sides were also 1. So if they were all 1, I know that this guy right here just got cut in half, so he was 1/2. And I know that the altitude, this other side, is the side that got cut in half, so it's 1/2 times the square root of 3. Okay, now here's my 3 sides of the 30, 60, 90 triangle I'm looking at. Okay, this guy, well, I need to erase something. This guy right here, on the unit circle, so I've got, that's 60, that's 30, that's 1, that's 1/2, and this is square root of 3 over 2. The 1/2 from my coordinate plane, the sign of that is going to be positive. The sign of this guy, this negative 3/2, it's actually going to be negative because it's below the x-axis. It's down on the y-axis. So they want the sine of 60 degrees. So the sine of 60 degrees is actually going to be, what is it going to be? It's going to be opposite square root of 3 over 2, and that's a negative, and opposite over hypotenuse, I divide that by 1. So the sine of 60 degrees is going to be a negative square root of 3 over 2, and that sine of 60 degrees, just from this right here, is going to be actually the same thing as the sine of 660 degrees. Now the bad thing is you're not going to be able to have a calculator to do this with, so you're going to have to use what you know about a 30, 60, 90 triangle and a 45, 45, 90 triangle. So they're going to give you easy triangles to work with, but this was a pretty tough problem. C, just because we haven't even gotten into the unit circle. Which of the following has a value of 64? B. I know that something cubed and something to the cube root, those are inverse operations, so they're going to undo each other, and it's just going to leave you with 64. Exponential growth by doubling, so it's like the problem we did. If you're hired and he starts with a penny and doubles every day, is defined by this equation: n equals n to the n sub 0 minus 2 times 2. That should be 2 raised to the t. Doesn't really look like that, but that's what it should be. N is the number of individuals at a given number of time periods, t. So t for time. And when n sub 0 is the original population. If the number of bacteria entered into a petri dish is 500 and it doubles every 2 days, how many bacteria would be in the dish in 10 days? So we got these numbers: 500, 2, and 10. So 500, that is going to be your original population. So n sub 0 equals 500. Doubles every 2 days. So 2 days. Let's put that for t. That's the number of time periods. And they want to know in 10 days how much are you going to have. So you are going to have, I'm going to plug this 500 into right here. So you're going to have 500 minus 2 raised to the, how many times is it going to double? If it's doubling every 2 days for a period of 10 days, it's only going to double. This is how many times it doubles right here, and I'm going to put a 5. It's going to double 5 times. So if I go 2 raised to the 5th power, 2 times 2 times 2 times 2 times 2, it's only going to give you 32. So 500 minus 32, but something's wrong because I don't even see that as an answer up here. I wonder if I did something wrong. 500 minus 32 is definitely not up there because I got 468 and I can't find that A, B, C, or D. Okay, n is the number of individuals at a given time when n sub 0 is the original population. If the number of bacteria entered into a petri dish is 500, so that's my original population, and it doubles every 2 days. You know what, this is kind of stupid. This is a lot better doing mental math. I think what they have given us here, I think we've got a bum formula. So if you just do the mental math, that formula, I'm wondering if it should be a plus sign right here. That would still give us an incorrect value. But if you start with 500 and it doubles, 2 days later you're going to have 1,000. So this is where you start. This is 2 days. 4 days you're going to have 2 grand. 6 days you're going to have 4 grand. 8 days you're going to have 8 grand. 10 days you're going to have 16 grand. So it should be C. That's pretty easy to do with mental math, but I'm not sure how this formula is working. Alright. Let's go to the system of equations. Okay, again, this is one of those problems. If you don't know what's going on, you can just start with your answers. Plug it in and see which one works. So if I plug in a 1 right there for x, 1 plus 1 is 2. Does it really give you y equals 2? So yes, that works. And does this one work? 4 is 4 plus 1 really a 5? So A works for the bottom, but it's got to work for the top. So let's try it for the top. 1 squared is 1 minus 4 times 1 plus 5. 1 minus 4 is a negative 3 plus 5. Hold on, I think I'm plugging in the wrong stuff. No, maybe I'm not. 1 squared, 1 minus 4 plus 5. Yeah, okay, that's not going to work. Because negative 3 plus 5 is... No, it does. I keep getting these confused. If you plug in a 1, it spits out a 2. Now I got to plug in the 4, and it should give you a 5. So it's going to spit out a 5 if I plug in a 4. It should be 4 squared minus 4 times 4 plus 5. Alright, so 5 is equal to 16 minus 16 plus 5. And 5 is equal to 5 because that zeroes out. So A works. A works for the top and A works for the bottom. So it's got to be A. And you need to plug in B, C, or D. Alright, 1/4 of a revolution around a unit circle is going to cover a distance of how many radians? Okay, the unit circle. That's 1, that's 1, that's 1, that's 1. So if you go and rotate 1/4 around the circle. 1/4 is going to be right there. And in degrees, we know that's 90 degrees. So 1/4 of a circle, 1/4 of 360 is 90 degrees. So 90 degrees, how do you convert that to radians? You're going to times that by pi over 180. And that's going to cross cancel with that, cross simplify, and you're going to have pi over 2. So B. 180 degrees is equal to how many radians? 360 degrees equals 2 pi. 180 degrees equals pi. And we just barely did 90 degrees equals pi divided by 2. So it's going to be pi. Alright, your function is x cubed minus 5. Find the inverse. So it's really y equals x cubed minus 5. Move number 1, switch x and y spots. So it's going to be x equals y cubed minus 5. And then solve for y. So plus 5 plus 5. It's going to be x plus 5 equals y cubed. Okay, now undo a cubed, you have to do cube root. So cube root and a cube cancel, so I got to take this whole thing and do the cube root. So your final answer, y equals the cube root of x plus 5. And that one is, that's a tricky one. That is going to be, it's actually going to be B. Okay, you got to remember this. They're giving it to you not in cube root form, they're giving it to you in exponent form. So the exponent of this guy is 1. So they're converting this and they're taking the x plus 5. Oh, x plus 5. And you look at this and you look at this. Which one goes on top in the numerator and which one goes on bottom? The 1 is going to go on top and the 3 is going to go on bottom. So it's x plus 5 to the 1/3 power. That's actually B. Alright, a division problem. Find the quotient of 2x squared minus 4x. Now this is actually a piece of cake because you're dividing by one term. So you can divide both of these top terms by the negative 2x. So how many times is negative 2x going to go into 2x squared? So on top, you're going to have a negative 2x divided by a positive, that's going to be a negative, and just an x. Then a negative 2x, a negative 4x divided by a negative 2x, negative divided by negative, that's going to be a positive. 4x divided by 2x is going to be 2. So negative x plus 2. Go with D. Divide to find the quotient. 6 minus I divided by 1 plus I. Alright, so it's kind of like square roots. You cannot have in the denominator, you can't have an imaginary number. So if you have 1 plus I, I'm going to multiply this fraction by a fancy 1 to get rid of that imaginary number. I'm going to multiply it by the conjugate of 1 plus I, which is 1 minus I. I'm going to multiply the top by 1 minus I. Here's what's going to happen. This is the difference of squares. If you multiply 1 by 1, you're going to get 1. If you multiply 1 by a negative I, you're going to get negative 1I. If you multiply I by a positive 1, you're going to get a positive 1I. And by design, those two now cancel. Now you got I times a negative I, so that's a negative I squared. And I squared is a negative 1, so you got a negative 1, so you really got a positive 1 plus 1, so your denominator is going to equal 2. So now let's do your top, let's do your numerator. Let's multiply these two quantities. Distributive property. 6 times 1, that's a 6. 6 times a negative I is negative 6i. A negative I times 1 is a negative I, and a negative I times a negative I, negative times negative, that's positive I squared. Okay, now positive I squared, that's the same thing as a negative 1. So 6 minus 1, that's going to be 5. And your middle terms, a negative 6i and negative I, is going to be negative 7i. So 5 minus 7i divided by 2. Let's go with B.